It's number 39 from section 10.2, and again we are given the velocity vector, and they want us to find the position, and we've got our initial position is also, well, in this case the initial position is 3, -2. This is my velocity vector, so we want to find the displacement. So just like we did in problem number 37, we'll just take the integral from 0 to 3 of the x component. That will give us the x component of our displacement, and we'll take the integral from 0 to 3 of the y component, and that's going to give us our y component of our displacement. This is just the natural log of t plus 1, and that's from 0 to 3. One over u du, natural log of the absolute value u, and then if we put 3 plus 1 we get 4, and if we put 0 in here we get 1, but the natural log of 1 is just 0, so that's our x component of our displacement. Here we'll write this as, well, this would just add 1 and divide. Take the antiderivative, and that's easy enough. Then we can put 3 in here. And we can, actually this is going to end up being 1 over, or -1 over t plus 2 to the first power from 0 to 3. If I put 3 in here, I get -3 plus 2 is 5. Minus, and then this is the negative here. I want to. Oops, wrong one. This will be the green one. This will be the F of B. So this negative sign goes here. If I put 3 in here, if I put 0 in here, I get 1 over 0 plus 2, which is 1/2. So that's this minus sign here. Negative times the negative is a positive, so I put these in tenths, so this is -2/10 and +5/10, which is just +3/10, or 0.3. So there's your displacement. Now remember, the final position is the initial position plus the displacement. My initial position was given as 3, -2, so I can just say 3, -2 plus the natural log of 4.3. That's just going to be 3 plus the natural log of 4. And this is going to be +0.3, -2 is -1.7. So there's your final position. Initial position plus displacement. And the distance traveled is just going to be the integral of the absolute value of the velocity, or the magnitude of the velocity vector. Same thing. That's the distance traveled from t equals a to t equals b. So integral from a to b of this. And then we're just going to square our horizontal component and square our vertical component. This was our horizontal component. This is our vertical component, way up, back up at the top. It's our velocity vector. So the square root of the horizontal component squared plus this vertical component squared, and then I just put this in the calculator. And again, you could have varred these also, but this wasn't quite as difficult. It's just the square root of, and then this is going to be x plus 1 and then I just multiplied. -1 times 2 is -2, so I just put x plus 1 to the -2. -2 times +2 is -4, so x plus 2 to the -4, put in parentheses. Put in your calculator, and that's your displacement, so it's not too difficult. Okay. So pretty much just using the formula and figuring out how to put it in. Like I said, this just might be a little challenging. You could have put this in y1 and this y2 and used, again, the var y vars, so this wouldn't be such a long expression. Hope that helps.